Okay, my wonderful friends, Roger Spur, Mudfossil University, everything falling on our side. Department of Physics, 23rd March 2021. Flavor changing neutral current transition. Well, Electron University violation means that they have to throw out physics. It starts to influence unknown physics. They don't know how physics works now because of literally the particles that I'm showing. And I have been showing them for years, and I know they've been watching this because they've been changing their attitude now. But it's glacial in the academic realm because they cannot speak out without being assaulted. Now, this is about lepton universality, changes the Bohr model. Bohr model's gone long ago. All right, so what is flavor changing? These are what they call flavors in the standard model, and they have some correctness, but not a lot. There is what is called an electron and a muon. Now, they are attached together when they are not concussing. When they concuss in the Venturi that we developed, they turn into electron showers, and the muon does not change. Now, they show them as electron neutrinos, muon neutrinos, electrons, muons, taus, tau neutrinos. This, I don't know about that. All I can tell you is that the electron turns into showers, the muon just doesn't change. The muon is dark matter, and it is also what they call the muon boson. It's the carrier of the electron. When the explosion happens, the electron, boom, the muon does the nothing. Okay, they're talking about here flavor changing, which means that the electrons change into electron showers. Muons don't change. They're talking about electrons and muons, and the muons do not change. The electrons explode and change into showers. I'm going to talk about something else that is more important, which is colors. And this is color charges. Now, it says color charge, a property of these particles that they think exist, and gluons related to the particle's strong interaction. In other words, that is where I'm going to show you the red, green, and blue particles in the theory of quantum chromodynamics. Okay, it's a little bit different than the other things people normally think of. The color change of charge of quarks and gluons, completely unrelated to everyday meaning of color. Sort of. It's still a frequency change between red, green, and then blue. And I'll show you this. I can absolutely prove this. It says the term color and the labels red, green, and blue became popular simply because of the loose analogy of the primary colors. That's just wrong. Referred to his colleagues as idiot psychologists for choosing a confusing name. This guy's the idiot. Okay, let's rummage around a little bit through some of my shots here. This is Fabien Boulay. He did some shots with green and red laser through the same slit at the same time. Now, you see how powerful that is? Let's go back to the next one down where it's green and red. See that? The red only comes out to here. The green would have concussed way out here, but it's banging into the red interference. And you can see a little bit of red, but they're the same particles. Now, let's just keep going. I got plenty of time. I don't know about you. This is Fabien again, and these are the particle spray. And that spray of particles, I'm almost 100% sure, is nothing but electrons. And the dark part is gone until they concuss out here. And I've seen this in about a zillion shots. This was where, I don't know exactly how he got this one, but you can see fields concussing into other fields. So there's some kind of really heavy-duty interaction going on here. Normally they come out in a spray like, oh, this is outer space. This was done, the Russians did. I think the Russians are the ones that did this. They fed electrolysis, which means just electricity, into this fluid, and when electrons blow up, they blow up into balls. These are electrons, or photons, or whatever they are. They're electricity expanding. Whether they must be adding together to create a bigger space and create a bigger circle around it, because that's what happens in space. They have a black circle around the white particles. Hold on a second. The Druid light circle, cloud chamber, rings. All right, well, this is something similar. This is electricity through a cloud chamber, through vapor, showing these are the electron patterns. I can't say much more than that, but you can see they're very similar to the Higgs patterns I'll show you. And this was just a blast of electricity, I believe. Rainbow Higgs. That's just separation of light. All right, this is my buddy Renz. These are all particles that are being manifested due to the fact that they're concussing with water molecules. And you see this again. What do you see what Renz did? Higgs, this is another, I don't know what that is. I just got that in here. Here's Higgs. Here's Renz again. Now this time that same picture is colorized, it's regular color. And you can see they look like rainbows. You see them? They look like little rainbows. But what happens is they interact with the water molecules. And I'm not sure what kind of a phone he has, but these are done with a cell phone. There's the sun back there. And I don't know how, there must be some settings. I don't know, because I could see some kind of settings going on there. This is a space shot. Oh, these are the same thing. I don't know who did this one. I got a lot of people working with me and helping me a lot. That's Fabian again. All kinds of light particles slamming together at the same time, back into other Higgs fields. These are, that's the enhanced Higgs fields coming at us. These are just after the Venturi, where the light is spinning. You see some going this way, some going that way. Well, it's because the light spins. Light is a spinner. It's not a flapper like this. It spins. So sometimes it spins and they go this way. Sometimes it spins and they go that way. Usually, most of them come through the center, because some will be over here, and they'll end up hitting the center most of the time. That's how that works. That's why you see them they have those interference patterns. This is all the different ones together. That's the light wave, the particles way back here. That's the wave, particle wave duality. Excited, accelerating, exploding, Higgs fields coming at us. Nothing in between here and the Higgs fields here except electrons. And if we can get something in between them and grab them, we're golden. This is what I call color change. This is red laser. That changed to purple. You see that? That is just highly unusual. That's the only time I've ever seen it. And so what I'm telling you is, we know that the particles are the same. The green, the red, they look identical. We can see this changing to purple from a red. So it's not the particle, it's the compression of that particle, the spin, because you can see it's crushed. And I found it, I saw it, I have other pictures of this. It's pushed in from this side and this side. And then it squirts out the end here like a cork. And this is the blue, whoops. This is the blue, and we can see it expands and compresses up there. So we know it's slowing down or speeding up, one or the other. That's the particle I showed a dozen times probably. That baby there is very, very unusual. And there was a reverse spinning white particle that came out in the midst of these Higgs fields. And then I found this, and I believe that's where that white particle came from. This is that Cherenkov. This is the spiral galaxy. And the reason these arms are twisted back is, the universe, everywhere in the universe, is filled with light particles. They didn't go nowhere. They go from there out. And they smash into things. So these arms are coming, and every one of them is separated. You see that with a black stripe in between. Exactly like the interference patterns. And the reason is this energetic particles are pushing out against these. They're pushing back. So you get a dark in between, because the dark matter in between is trying to drag them both together, and they're both saying, no, I don't want to go there. I'm pushing apart. They glow. It darkens in the middle. They're crushing into all of the particles that are in space that were emitted by everybody else in space. Now everybody else is emitting stuff too. So they eventually, just like cranking a wrench, and it just crushes this. We're in one of these arms. Sooner or later we're going to hit something, or we're going to go into a blank spot. So nothing is stationary. Nothing is stagnant. They say, oh, no, nothing's ever going to change. Yeah. Good luck to you, my friend. All right, so now that was the spiral galaxy. This, I don't know, maybe they knew all this stuff long ago. I have no clue. They knew something. Well, let me put it this way. They did know a lot more than we give them credit for. A ton more. Here's Renz. Look at this. Check this out. He puts his finger up, and he gets Higgs fields coming off the half of a Higgs field. We usually have what you would consider just like this. It hits between the two, and they spin and start spinning. He's got a half of one. He's got one that tumbled. Where do you see this? There it is. There's the tumbler. See it? There's the disk. Here's the red, blue, green. It's splaying out. You see the red is much longer. The green is a little less. Then the blue just barely. You lose it way up in the front. This is a white Higgs, and it's tumbling. It's coming off them, and we're seeing it manifest itself, and then we're seeing it tumble. That's the only time I've ever seen that. What else we got here? Starlight, star bright. These are green electrons showing how they get manifested within the laser. There's the actual particle. Oh, they show these things. These are little clips of somebody just decided sound bubble wave model. I don't know. They have all kinds of ideas, but I'm showing you things. Look, this is real. This is actually what comes out of the red green laser. Now they're showing this exactly what I'm showing here. I forget what they call it now. There's a guy that did a mathematical model of how it spins around and whacks here against a secondary field that's over here, and he's relating it to prime numbers. Very, very interesting. I did a video on it, and I'm going to show all the stuff I have. I have so much stuff, it's just absolutely stunning, the amount of information that I've accumulated over the years of doing this. That's the blue laser. And I believe that is going through glass, but I'm not even certain of that. Harvard was doing something very similar to what we're doing. See this? They're shooting this through this and that and trying to activate it, but it's got the same thing. Same thing. They put little plugs in here and plugs in here, but just the stuff that we're doing, same stuff, and then they throw one out and everybody goes home. Like they're big shot. Get to the end of the story. There's the electron coming through, manifesting, exploding. Blue trail, there's the blue shot going on. And it's very obvious that it's wide at the bottom and compressed at the top. Something's going on there. It's not the same speed, obviously. Whatever this is, magnetic waves. That's another little doodle somebody did. But it's not far off. But this is the real. This is the real deal. That is a drill bit. And the reason is light spins. Precisely like this. And there are particles all over the place. So some of them are hitting here, and they're hitting here, and they go way over here. Some of them are just hitting way over here, and they just barely get to here. Some of them over here, and they just barely get to there. So it's all over the place coming through, but primarily you're going to get a circular pattern, and you're going to get interference between where they come through. Get out of my way, you get out of my way, you get out of my way, you get out of my way. Because all you're coming through here is with the white ones. The black ones are gone. You can't even see them. This is a different type of a shot, so you won't see the black ones in this. This one here was a strange one. This is the white particle, and I'll show you this in a minute, came through backwards, hit this disk, and produced that, whatever that is. So it's not a normal Higgs field, it's not the muon, and it's not an electron. That's my estimation of what it is not. Now this one here, Jay Hoskins sent me this. I can't remember what this was about, but it's interesting. Rainbow showers. Okay, now this was the one where that white particle came out. Now don't forget, I'm saying this is the Venturi coming at us. See that white spit right there? You see them all here? From here to here is nothing but an electron. If we could put some kind of barrier between there and there, so that it has to be absorbed or it has to be used before it can get back to that black particle, and we can harvest that extreme interaction, we have free energy. It's just like chaos. These are the Higgs on the moves. This is where it got crushed. You see it? These all started red. It was the same color as these coming out. Now it's blue and it squished. Then it starts to squirt out like a rocket ship. But it's coming back to the same color. So that was, I found, very interesting. Samsung phones. We did this with the Samsung phone. I just reached out to Samsung. I said, you should help Rod. Rod's the one that's doing all this. You know, I do the the atomic theory. Rod is an experimenter guy. He's not into this like atomic stuff at all that I know of. But he's damn good at making these shots. I don't know how he does it. Whew. That's the accelerated particle exploding. Nothing but raw energy. They claim this is 200 times at least more energetic than a black particle, or vice versa. I don't care which one you claim has the energy. When they come back together, that is an explosion. When they're separated, an explosion. When they come back together, I suppose it's damn near the same explosion. But you got to get in between them, and then you can harvest the energy. And then, of course, there's Fabian, and he shows the thing all colorized. And there they are. That's the leading edge. It's getting bombarded with energy, and it's going to flip and spin and all that, and those are the spikes. I'm going to leave it at that. Thank you. I love you all. All right, this is a green photon. Photons are two electrons. That's an electron, that's an electron. They're bar magnets. Nobody ever knew the black particle was there. They always thought it was just a concussive particle that created light and interaction and heat and so forth. Well, no, they're attached. Back to back, bar magnets, they become a photon. A photon hits and bounces because it doesn't want to absorb. It will smack into something and warm it up because it banged into it, but it will not incorporate into it like that will. That will zzz right into you. And that will jump on, if it's all by itself, it will hang on to other polar molecules that are in the air. What's a polar molecule? It's one that has that kind of a interaction that it wants to grab onto one of these or the other. So it snaps on there. Well, it really would like to be in the ground. That's why they say always ground everything. What does that mean? Ground everything. Well, it means run a wire from the thing into the ground. That's what it means, literally, because the Earth sucks electrons. Now, this gives you a real good idea of how they are. They're coming flying this way from a red laser. They're really rocking. They're going. So they have some kind of an interaction pretty good against what's out here because it's a magnetic wave. And then it starts to crush back against it. And then they display. And then they glow. And then they explode. And I'll show you what happens when they explode. Now, the red laser pulses. It starts to accelerate because of this Venturi. It explodes at the Venturi. The black balls, which were attached to the white balls, they originally look like this. The black ones just get out of the way, the white ones explode. Muons, electron neutrinos, electron showers. When they're just attached together and floating around, that's an electron. When the two of them back to back, it's a photon, creates fields around. All of them have a field. When they concuss, they explode. This is exactly what we did. That's the red laser. Boop, 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 boop. The particle is way back here, but the field that it influences way out here concusses all these other fields. They glow. That's the excitation of the acceleration because of the Venturi. And you can see there's a hell of a lot more energy here than there was back here. So what does that mean? That means that we have increased the value of this, and I believe that's free energy. Between here and here, there is nothing but electrons. Now remember, we showed that's the particle, and that particle is what, whoops, that particle is what concussed here. The black parts went away and came back here instantaneously. I mean, that's instantaneously back. Now, whoops, hold on. You know, that was an accident, but you know what? I'm going to leave it at this. Come up here, and if you want to see more about the atomic interactions, I did this one. It says, does this atomic model work 100%? That's the name of the video. Can you see that? Now, and I think it's damn good. Watch what happens when they pull that thing back and he lets it go. Watch this. It hangs in on the extra electrons. There's a cloud of them. Back here I show about what CERN's looking for, and then I show our light acceleration and all of the whole thing, and then I show about the electron flood theory and how the core is constructed. I'm going over this a million times, but you know, people aren't paying attention, and then once it's up there for a day or so, it's all over, and nobody comes up and watches it at all. So I'm going to do it over and over and over until somebody confronts it, and then we can have a discussion. So, see you tomorrow.